So, towards the end of this presentation, I'm going to try to plug my laptop back in, so please bear with me. But for now, the slides, I'll just fly through that. So, there's varied maturity levels across AGL right now, right? So, with the P2P team and the new energy guys, this was the first project that they've done. But if you come into James's world, they're building out patterns where one click, they spin up a subscription, they spin up all the required services, the right service principles, and all of that. Like there is a lot of automation in the pipeline, just enabling developers to move forward. So I am in a position where, so I was kind of governing this project and helping them out when they needed it, but my primary focus at AGL has been microservices development. So what's next for the company, right? I'm quite sure what's up there. Yeah. All right. So as Michael has already mentioned, AGL is primarily in Azure, and there's quite a big footprint on-prem as well. There's a lot of digital transformation work happening, but everybody moving to the cloud all at once is not going to happen overnight. So how do we cater for it, and how do we help the business grow and deliver on business value while this transition is happening, and do it in a way where one doesn't become a blocker to the other, right? So having all of the workload within in a single Kubernetes cluster or multiple Kubernetes clusters, or is never ever going to be the case. Or all of it being in one cloud is never going to be the case. There could be different business units wanting to use different cloud providers. But none of these services will ever live in isolation ever. There will always be a point where you need them to connect to each other. So, how exactly do you solve for this? You have a lot of networking overhead. You have dedicated teams that are constantly making sure that all of the services are running over secure channels. And also transitioning into the cloud brings focus, it moves away focus from having host-based infrastructure to service-based. So you start treating all of your infrastructure as cattle, right? Infrastructure will spin up and will go away. So what exactly happens to the services? When your service is dynamically scaling out, do all the other downstream and upstream services know of this? And how exactly does this load get load balanced? And when there's no demand and it scales back in, how is all of this managed? So you need some sort of service discovery mechanism. And also enabling cloud agnostic capabilities, right? So back to Michael's point about how feasible it is for you to actually lift and shift your entire application from one to another is, I don't quite buy that. There's always going to be a need to have a multi-cloud strategy. You want to pick the right tool for the right job. Let's say you have a lot of deep learning work happening, and you're building a lot of models all the time. And the right hardware for it is probably in Google, right? There are other instances where you want to build a data warehouse for some reason, and AWS is much better at it. I'm just pulling this out of thin air. So you still want to leverage the right place. You want to have your right workloads in the right place. How exactly do you go about that while not completely isolating these services? You still want them to talk to each other. If the model is being built in one place, how exactly do you consume it from another application? So these are the problems that we're actually looking to solve. So that is how we've actually ventured into the whole service mesh stuff. And our requirements around it have been pretty much like this, right? We wanted a service mesh that was battle tested, which has been around for quite some time. We want to make sure that there is a good open source community around it, as well as we know that we are not early adopters of something. This is a big enterprise, millions of dollars are made. You wouldn't feel comfortable rolling out services which haven't, I wouldn't necessarily adopt a technology that is extremely new, or there's not enough of a use case around it, or not enough people have used it. Does it have a primary support for Kubernetes? So, as I've discussed earlier, most likely all of those workloads aren't going to be Kubernetes. So, how do we cater for that? We need to be able to cater for just on-prem stuff, as well as your containers, as well as if somebody else wants to use another container orchestration system, how do you cater for that? Security, right? This could be just a security profile of the application, how many vulnerabilities have been out in the past, what sort of time window does the vendor respond in, and also does it actually help secure your systems? Is it lightweight and easy to use? Does it have an easy UI? How much compute is this actually consuming? So if you start to scale out a lot of microservices and you're provisioning compute in a cluster, and your service mesh itself is using up to 30% or 20% of the compute infrastructure, that's not great. So I'm kind of hinting at Linkerd. I've had a lot of issues with it in the past. Linkerd 2 is apparently much better, but I haven't had a chance to play it. They rewrote it from Java to Go and Rust. I'm guessing that helped it. And is there enterprise support for it? So if things go wrong, can I pick up a phone and call somebody and ask them for help? Is there going to be some sort of SLA around it? If there are systems that are accepting incoming payment, can I accept downtime on it? If there is mission critical systems where, I don't know, there's some application running on over there that is coordinating some some thermal power plant or something of that sort. And you really can't let it go down. Or if there's an open market where you're bidding, something like P2P, can you actually allow for any downtime to be there on it? So that's where the enterprise support comes in. Is it extensible? If I have a need to actually extend it by some means, will I be able to do it? Is there an open source version of it, or is there a plugin ecosystem for it that I can either write custom plugins for or lean on community for it? And then again, multi-cloud capability. So this is not just Azure, GCP, and AWS. I'm also thinking about public and private cloud in this context. Right. So Consul kind of fits most of these, pretty much all of these needs that we had. So this is a very high-level view of what Consul does. So you have it's bridging to data centers. You have a quorum of servers, which is basically it does leader election. It is fault tolerant. If there is so it's n-1/2 tolerant, right? So if you have a quorum of 3, one failure is still fine. And these servers can actually sit in multiple clouds, multi-region, multi-clouds, and they all can actually tailor together. If it's business critical systems, then you have a quorum of even 15 servers, that's pretty good. You can actually split it between clouds and have them all orchestrated with each other. And all of the communication that all of the services exposed are all over encrypted channels, right? It does mutual TLS. It has its own CA internally, or it can plug into HashiCorp Vault, or you can extend it to whatever you want it to do. I think there are also providers. Most of HashiCorp's applications have a concept of providers, be it Terraform, be it Packer, or even Consul. You can extend stuff as a plugin ecosystem. So yeah, so Consul is a distributed service mesh to connect secure configure services across runtime platforms and public or private clouds, right? And also it is enterprise ready. I think today Consul went live 1.4 and it's stable with Consul Connect. And this Consul, I have native support for Kubernetes, right? So Kubernetes services. So now, since I'm talking about a heterogeneous system over here, where there are multiple services, be it within Kubernetes, not in Kubernetes, you want them to talk to each other. But once you publish a service to the Consul, it can translate that service into a Kubernetes native construct. So you you can inject the sidecar into whatever service you have. That's the feature called Consul Connect. And the way it exposes it is you can't quite tell the difference. You can have a workload sitting in Kubernetes that talks to some VM sitting somewhere. And also, Consul Connect. So I had a tough time actually understanding what this was. Initially, when I heard it, I thought there were two different products. So Consul Connect was the enterprise version of it. It's not quite the case. Consul Connect is available even in the OSS version. And all it does is that it orchestrates Envoy. So all the goodness of Envoy, your layer 7 filtering and your L7, L4 filtering and doing a lot of header inspection and things of that sort, all of it comes along with it. So that is pretty much the end of this thing, and I had a demo to actually demonstrate how exactly you can publish a Kubernetes native service or any other service on your own VM and get them to talk to each other. Get them to talk to each other in a secure manner, and have it all mutual TLS done and show high availability when a node goes down. And then there was a second demo that Gus was going to help me out with, where we had one cluster and another VM sitting outside of it, and then we had the VM join the quorum of servers of the Consul server, and it treats everything as one data center. So you can actually start have all the communication happening. So this VM could be your own personal laptop that you're plugging into your service mesh, or it could be say a Nomad cluster, or it could be just VMware box sitting somewhere in a shell.
Hey guys, what's going on? It's Gus here, and I'm here today to talk to you about service meshes and Consul. We'll go through a really quick brief overview of Consul, and I'll give you a demo on how we can do a service mesh to map a container-based workload that is Kubernetes to be able to talk over a service mesh with mutual TLS and HTTPS to a VM running outside of the cluster with a Java application, for example, a legacy Java application. So to get started, this is the Consul website, consul.io. A lot of information you can go and find here. We'll be using the HashiCorp's Consul Helm chart, which does a lot of the stuff out of the box for us. So obviously we'll be using Helm and we'll be using Kubernetes. So the first thing, I have set up a little Google project here with a Kubernetes cluster, a pretty simple cluster that has 3 nodes. And we'll be using this to set up our Consul servers and agents. And then we'll set up a virtual machine that allows us to create the service mesh and show the functionality. So let's get started. So firstly, I've got a cluster here. It has pretty much nothing in it, and except for Helm's already been installed. So what I'll be doing is installing that Helm chart, and I'll be cloning the Consul Helm chart into a temp Consul directory, just for the sake of this example, and then I'll be installing it from there. So there are a few flags here that are important. Actually, before we do that, let's create our namespace. We'll create a Consul namespace for all the stuff that we're creating. And we will be installing our Consul Helm chart. We'll be enabling the Consul UI. We'll be using the latest Consul image, which is version 1.4.0. We'll be using the connect inject, which is an admission controller that allows sidecar containers to be attached to your pods when you deploy them. And we'll also be turning on gRPC so that the service mesh actually needs that functionality to work. And finally, we will be installing everything in the Consul namespace. So that should be just a few minutes. There you go, pretty quickly. So some of the stuff that gets installed is some config maps, the injector webhook. So that is what is responsible for attaching your sidecar containers. It has 3 agents and 3 servers. So you can see they're still pending, but that should probably be done by now. Some service accounts, some basic stuff under the hood. And some of the stuff like the agents, they're daemon sets. So if we get everything in that namespace, in the Consul namespace, you should be able to see there is our daemon sets, and I've got a Kubernetes cluster with 3 nodes. So we have 3 versions of the agent. So that's all cool. So I'll show you now how to get access to the web UI. So to do that, we do a port forward into any of the servers. So in the Consul namespace, we have the Consul server 0, for example, and the port 8500. And they should get the web UI for us on localhost. Cool. So here you can see I pretty much have nothing in there. So Consul itself is registered as a service inside, and we can see the nodes. So there's 3 servers and 3 clients. It's part of the pool. It has some intentional key values that we'll get around to later. So that's it. That's all you need to get Consul up and running really quickly. So next up, I'll start a virtual machine outside of our Kubernetes cluster, and I'll have that run Consul and connect to this service mesh. So to do that, I've taken a little bit of preparing an image for us with some stuff already installed out of the box, but there's only really 3 things. This Consul, the Consul agent itself. There's a Java application, just Java jar, pretty simple. And there's also the Consul Connect proxy, which is the same binary as Connect, but it's actually running as a proxy for our Java application. So let's get that sorted. So let's call our instance just Consul. You'll be in Sydney, which is where I have the Kubernetes cluster in, but I don't think it matters. It can be anywhere so long as it has network connectivity. A small instance is fine. I'll use my custom image that I've created previously with Packer, and I'll give it pretty permissive rights, but truthfully, all it needs is to be able to access Kubernetes GKE in Google. So we'll get that rolling. So once this is up, I'll SSH into it, and I'll show you guys some of the configuration that's in there. And I need one more. I need to actually get or provide the Kubernetes authentication, so the kubeconfig file, to the Consul service, so that I can auto discover and auto join the pool of nodes. So yeah, the instance is up, and I should be able to grab the Google Cloud command, and I will SSH into it. So I'll get out of the port forward for now and SSH into it. Cool. Instance is up, and I'll show you the 3 services I was talking about. One is called Consul. You can see if we go into status, it hasn't connected to anything just yet. You can see some of the configuration here. It's just Consul agent, and it's using the Kubernetes provider. It's targeting a specific set of labels. It's expecting to find the Kubernetes config file under opt kubeconfig, and the namespace is Consul, and some directories where it saves data and configuration. On top of that, we also have our Java application, which is a payment. It's called payment. You can see there, it's just java-r and the path to our Java file. Pretty simple, pretty straightforward. It is running under port 8080, so I can localhost, or I can curl to localhost 8080 and I should get a response. So that's all working fine. And finally, we've got the payment proxy service, which is the Consul Connect proxy that will allow us to connect to our Java application via the service mesh. And this is all fine with errors for now because we haven't finished setting it up. So the one thing we need to set up is to get our Kubernetes configuration here. And to do that, we can just go to the Kubernetes engine and grab the command that we can just run in our VM. So that's the command. And given that the VM has pretty permissive permissions to the Google APIs, you should have no problem pulling down that credential. Great. So now that credential is under my local directory config, so you can see it there. I will move it to the appropriate place. Config to opt kubeconfig, where Consul expects to find it, and we should be able to just wait now, and Consul should find everything it needs. Oh, there we go. That's pretty quick. So you can see it auto-discovered three servers here. So it's joining all 3. You can see there are 3 servers and 3 clients, which are also running Kubernetes and ourselves. That's awesome. So from now, our proxy should also be up and running. As you can see, the servers have been synced. Both the payment and payment proxy are good to go. And I can show you these guys again in our UI. And to do that, I'll do the port forward again. So if we go back into our UI and just refresh, you can now see both the payment and payment proxy are great. They're part of our Consul has registered them, and I found both of them. You can see which node it's running in, one healthy node, and all the health checks are passing. Awesome. So to actually complete the loop of functionality, we'll launch a pod in our Kubernetes cluster that is also going to join the service mesh, and we'll try to get access to the Java application through that pod using Consul service mesh. And to do that, I've got a little client pod that I've written before, and so it makes use of some annotations. So these annotations are how you interact with the Consul admission controller, and how you specify that you want a sidecar to automatically be injected, and you also have to specify which service you want to get access to. So in our example, we're using the payment service, and we're going to map it to a local port of 20,000. This could be any port that you'd like, and this is how the service mesh is going to allow us on the loopback network interface to connect via the service mesh. So let's apply this guy. Cool. It's going to take a couple of minutes for it to get ready. Still initializing. And once this is up, we can exec into our container and do some curl requests to show how how this all works under the hood. Cool. It's up and running. Just before we get in, I can show you that there are now a couple of containers. So if we describe a static client, you'll be able to see that there's an init container that was part of the Consul Connect inject stuff that we enabled before, as well as our application container, which is a static client, and our Envoy sidecar proxy. So that looks to be working all good. So if we exec into this container, So this is the static client. So that's the static client pod and the static client container. We're going to open up a shell into it. Fantastic. And you'll be able to see that Consul injects some environment variables for us to know what service is running under what port. So for example, the payment connect service port is 20,000, like we specified in the annotation, and the host is under localhost, which all the service mesh enforces a localhost loopback. So if we try to curl localhost 20,000, you'll be able to see we get a response straight away. So that's awesome. So that's all working under the hood. So that is pretty much the basics of the Consul service mesh. So this is a pod running on a cluster, making a request via the service mesh to an application that is running outside of the cluster in a VM that is just an old school Java application, for example. And actually for this one, I can do a more interesting curl request. Cool. So this is a more interesting curl request. So this is a request that the application actually understands. And it's a post request. And this is a payments application. So essentially it tells me that I have insufficient funds. So for us to do some more cool stuff with Consul Connect, we will now be playing with intents. So I'll be doing multiple requests here just to show you some of the functionality of Consul intents and how it all works like a firewall, like a dynamic firewall, when I can specify that a specific service, like my static client service, can go or is allowed or is not allowed to talk to another specific service like the payment service. So we can just keep sending these requests. Cool. So this is a request that it understands. And now I will go back into my VM. I'll go back into my VM and I will issue some Consul commands. So here we've got Consul installed and we've got our service installed. So for example, we've got our payment service installed. So if we do a status, you can see it's doing some stuff there, or even better than that. We can query journal control, payment. You see it's receiving and doing a bunch of stuff. Receiving a request, logging some stuff, new payment, that's Nick, so that's us, we're making that request. And obviously we're missing some information, but the application is working. Just to show that this application can stop. So if we were to stop, our curl request should start failing now. As you can see, connection reset by peer, doesn't know what to do, and we can start it back up. And once the proxy is able to pick it up, it should start receiving requests again. So let's check. Oh, there we go. It's already there. So we can check the proxy settings. So service control, payment proxy, that user. And you see it took a while, but eventually re-registered with the payment gateway. So next up, so now that we have Consul here installed, we can start issuing some intentions. So we can query the service catalog with the command line. So catalog services. So you can see we have 4 services registered here. One is the static client, our payment and our payment proxy and Consul as well. And we can now we can issue the commands to do the firewall kind of scenario. So with intention, we can go create or delete some dynamic intentions based on our service names. So say we want to deny the static client from talking to anyone outside of our mesh or anyone anywhere. So we can pretty much create a deny rule that says the static client cannot talk to anyone. And now our connection starts failing because the static client, which is this pod here, is not allowed to talk to anybody. Similarly, we can go and delete this rule. Things should start working again. On top of that, we can be very specific, and we could pretty much, for example, deny anything to talk to the web or to the payment proxy, for example. So payment, and so static client is no longer allowed to talk to payment. But similarly, we can be a bit more explicit and say, oh, no, actually, we want to allow only the static client to talk to the payment proxy. And now everything is working back up. So in a really quick brief thing, this is an introduction and a demo of the Consul Service Mesh and Consul Connect running on Kubernetes with a VM outside of the cluster. Thanks, and I'll see you next time.